Welcome to Math TV with Professor V. It is Friday, February 10th, 2023. Here's your integral of the day. We have an indefinite integral of cosine of natural log of x dx. I actually had my students in Calc 2 do this one the other day. We did like a little substitution first, but for this video, I'm just going to jump straight into it. You need to use integration by parts. How do I know? Well, if you try to do a U substitution, it doesn't get you anywhere. It just gets you to a more obvious place where you need to do integration by parts. So I'll let you play around with that if that's necessary. But otherwise, I'm just going to hop straight to it. Choosing U and dv, you're just going to have to look at it and say, well, I don't really have a whole lot of options because obviously I don't know the antiderivative of cosine of ln of x. So there's no way that could be dv. That's going to have to be u. I can't anti-differentiate it. So this is cosine of ln of x, and then dv is just going to be dx. This is much like how we come up with what the antiderivative for natural log of x is in the first place. Okay, then du, don't forget you need to use the chain rule. So derivative of cosine of natural log of x is going to be negative sine of natural log of x. Then I have to multiply by the derivative of natural log of x, which is 1 over x, and please don't forget your dx, unless you want -1 on your paper. That's what I tell my students. Okay, and then if dv is dx, then that just means v is equal to x. All right, so here we go. So we've got uv, that's going to be this product right here. So x cosine ln of x minus v du, this product right here. Since there's another negative, that's going to turn that positive. And then I have sine of natural log of x over x times v is just x dx. So probably you already noticed, ooh, these x's cancel out very nicely. Do things look much different? Look at what we're trying to integrate now compared to the original, and it looks very similar. Not much has changed. It's not like it's a polynomial that's gone down in degree, so now I can integrate or anything like that. In fact, I'm feeling like this is going to be one of those cyclical problems where it's going to boomerang and come back at me. So I'm going to call the original antiderivative that we're trying to evaluate I. So let's keep in mind I is equal to everything I've written on the right-hand side. And now I'm going to repeat the process and do integration by parts once more. Choose u and dv in much the same way, but call them something else. We already used up those variables. So u bar is sine of natural log of x. dv bar will be dx. And then du bar, so take the derivative of sine of natural log of x. It's going to be cosine of ln of x times 1 over x, so divided by x dx. And then v bar will be just x. So watch what we have going on. We have I, our original integral, equals x cosine of natural log of x plus, now we have u bar v bar, which is x sine of natural log of x minus integral du bar v bar. So I'll write everything out. We have cosine of ln of x over x times another x dx. And then yes, just like in the last step, these x's cancel out. Do you notice something? Our boomerang has come back to us. This integral right here, cosine ln of x dx, that's the original integral we had. We called it I. So please replace this entire last term here with I. And then evaluating this antiderivative or integral simply boils down to solving for I, like you would any other variable. Okay, so how would you solve for I? Well, I'd group all the i's on the same side of the equation. So I'm going to add I to both sides like this. 2i equals x cosine natural log of x plus x sine natural log of x. That one's ugly. Let's fix it. Yes. And then last step, to finish the problem, we need to solve for I, get it by itself. So I'm going to multiply everything by a half, same as dividing by 2. And so you can write I equals, or you can just write the original integral cosine of ln of x dx equals 1/2. You know what I'm inclined to do is factor this x out with the 1/2. X. And then we have cosine of natural log of x plus sine of natural log of x. And then here's the dangerous part. You just have to have your wits about you and remember to put plus c. You know, because when you solve for I, that's when you actually end up with getting the integral complete, but you didn't really anti-differentiate in a way where you know, naturally put the plus c. So you just got to remember, hey, this is an indefinite integral. I better slap a plus c on there. Otherwise, it's -1 for me. Oh, yes. So hope you enjoyed the integral of the day. Give it a thumbs up. Leave me a comment below. I love to read them. Hope everyone has a lovely Friday. My classes have their first set of exams coming up, so I think they're going to do great. It's an exciting time. Great spring semester so far for me. I hope everyone else is doing well. If you haven't subscribed to my channel, please do so. I would so appreciate your support. Share this video with your classmates, friends, family, anyone you think that would like it. And check out all my playlists. I have video lectures on Calc 1, 2, 3. And I'm also on TikTok and Instagram at Math TV with Professor V. Take care, you guys. Bye.